Hello students and welcome to Smartkidz tutorials. In this video we'll be solving a set of MCQ questions, multiple choice questions on the chapter of polynomials. So this would be the first set of polynomial questions that we would be solving for MCQ. There will be much more after this. This is a set of 10 questions and this is from the NCERT exemplar MCQs for class 10. Okay, so let's begin, and these are the type of questions that you can expect to come for your exams as well. First one, it says if one of the zeros of the quadratic polynomial in brackets k minus 1 into x square plus kx plus 1 is minus 3, then the value of k is, and we've been given three options: a 4 upon 3, b minus 4 upon 3, c 2 upon 3, and d minus 2 upon 3. So if we can write over here to solve, this is how you solve it. If minus 3 is one of the zero of the above polynomial, then it must satisfy the equation k minus 1 in brackets x square plus kx plus 1 equal to 0. So what the statement says that if we put minus 3 in this equation, then the value should come equal to 0, because that is one of the zeros, and by doing so we will get the value of k. So let's try it out. Remember, this bracket is multiplied only with this term, that is x square, not with the entire polynomial here. Okay, so k minus 1 in place of x square will be minus 3 whole square plus k into minus 3 plus 1 equal to 0. And you have k minus 1 minus 3 whole square is 9, minus 3k plus 1 equal to 0. 9 into k will be 9k minus 9 minus 3k plus 1 equal to 0. 9k minus 3k gives us 6k, and minus 9 plus 1 will give minus 8 equal to 0. So we take 8 on the other side, it will become positive. 6k equal to 8, 2 3s are 6, 2 4s are 8. We will get k is equal to 4 upon 3. So our correct answer is A, 4 upon 3. Next question, a quadratic polynomial whose zeros are minus 3 and 4 is, and we need to find the quadratic polynomial. So to find the quadratic polynomial, we will write it as x square minus alpha plus beta, that is the sum of the products, into x plus alpha into beta. So we'll take the two zeros as alpha and beta. This is minus 3 and 4. We'll get equal to x square minus alpha will take as minus 3, beta will take as positive 4, to x plus minus 3 into 4. Okay, this dot represents the multiplication sign, that these two numbers are being multiplied. So x square minus 3 plus 4 gives us positive 1x. So instead of writing positive 1x, we'll just write x. So minus x we get, and minus 3 into positive 4 gives minus 12. So this will be minus 12. Okay, but if we have a look over here, none of those match our choices. We have x square minus x, that is the closest that it comes to, positive 12, but we have got minus 12. This does not match because it has a positive sign. What if we divide it? If we divide it, we'll be able to get this answer. Let's have a look. So okay, we keep this x square minus x minus 12 and divide throughout by 2. Let's see what we'll get. Okay, in that case we will get 2, 2 and 2, which will go on to become x square upon 2 minus x upon 2 minus 6. So yes, it does go. So C is our correct choice. Let's mark that. Next question, if the zeros of the quadratic polynomial x square plus a plus 1 into x plus b are 2 and minus 3, then we need to find the value of a and b. So there are two zeros given, so alpha will take as 2 and beta will take as minus 3. So alpha plus, before that we'll just compare this to the general form. So comparing to the general form, we'll get a equal to 1, b equal to a plus 1 and c will be equal to b. We are looking at the coefficients of the variable x and the constant. Then alpha into beta will take first, equal to c upon a, that is our formula. Alpha we've taken as 2, so 2 into minus 3 equal to c. C we've got as b, a is 1. Okay, so we'll get b equal to minus 6, and alpha plus beta is equal to minus b upon a. Alpha is 2 and beta is minus 3. 2 minus 3 equal to minus b. So b is a plus 1 whole thing upon a, which is 1. Okay, so 2 minus 3 gives us minus 1 equal to, I'll open the bracket, minus a minus 1. Okay, take a on the left hand side and bring this minus 1 on the right hand side. We'll get a will become positive, minus 1 plus 1, that gives us a equal to 0. So which one is that? A is 0. There is only one option where b is also equal to minus 6, which we have got over here. So that means D is our correct choice. Question 4, the number of polynomials having zeros as minus 2 and 5 is, so first we'll have to look what polynomial we get actually with that. So if we take x square minus alpha plus beta into x plus alpha into beta, let's see what we get. Alpha will take as minus 2 plus 5, beta is plus 5, x plus minus 2 into positive 5. Let's get x square, and minus 2 plus 5 gives us positive 3, so that will become negative 3x. Minus 2 into positive 5 gives minus 10. So we get this polynomial, okay, but we are asked how many polynomials are actually possible. So there are a number of polynomials that are possible, because this actually translates into x plus 2 into x plus 5. Okay? So when we take this equal to 0, we will get x equal to minus 2 and x equal to, this will be x equal, this will be x equal x minus 5, x plus 2 into x minus 5. So when we take x plus 2 equal to 0, that will give us x equal to minus 2, and when we take x minus 5 equal to 0, it will give us x equal to positive 5, like this. But there are other options also possible, like for example, even if we take it this way, x plus 2 whole square x minus 5 equal to 0, or for that matter, you don't have to write equal to 0, but okay, x plus 2 into x minus 5 whole square, or x plus 2 whole square and x minus 5 whole square. All these will give us these zeros as minus 2 and 5. Okay, so and you can continue going on further, because all this will give you minus 2 and 5 as the zeros. So it just tells you that more than 3 zeros are possible. Okay, no, sorry, more than 3 polynomials are possible with these two zeros. Okay, so our correct answer is D. Okay, you can continue. It will can also go on like x cube, x minus 5, or x plus 2 into x minus 5 cube. All this will give you minus 2 and 5. It's just asking you how many polynomials are possible with this, if with these two numbers as zeros. Okay, so there are a number. We can continue with this. So from the choices that are given to us, it is definitely more than 3. Next question, if one of the roots of the real quadratic equation is 2 minus root 3, find the equation. Now this question has come for the National Talent Search examination as well. Okay, so the options given are here in front of you. If we say that if one of the roots of the real quadratic equation, so quadratic equation will be x square something something, is this, that means it has to satisfy that. Before that, if we say that, that means we can take this x equal to 2 minus root 3, right? If this is, if 2 minus root 3 is a 0 of that quadratic equation. If we take 2 on the other side, let's see what we get. X minus 2 equal to minus root 3. You square on both sides, squaring on both sides, we'll get x minus 2 whole square equal to minus root 3 whole square. Okay, x minus 2, a minus b whole square this is, so a square minus 2ab plus b square. Okay, this is what we get, equal to minus root 3 whole square will give us positive 3. Okay, bring 3 on the left hand side, it will become negative, and we'll get x square minus 4x plus 1 equal to 0. Do we have this in our option? Let's say x square minus 4x plus 1. Yes, this is the one. So B is our correct choice. Next question, and this has also come for the National Talent Search examination. It says if x square minus 3x plus 2 is a factor of x raised to 4 minus px square plus q, find the values of p and q. This is a polynomial, and it says this polynomial is a factor of this polynomial. Okay, so we'll see, we'll have to split this to actually get the values of x. So x square minus 3x plus 2, this we can split. If we split the middle term, it will come as x square minus 2x minus x plus 2, that will be x into x minus 2 minus 1, I'll take as common, x minus 2. So that means x minus 2 into x minus 1. Okay, now that will mean that x equal to 2 is one of the zeros and x equal to 1 will be the other 0. Now if we take f of x equal to this polynomial, that is x raised to 4 minus px square plus q, okay, and we substitute these two values separately in this, then we should be able to get p and q. Let's see how. So if this is if we say these two are factors of this, that means f of, let's say we'll take 2 equal to 0, will take substitute. So f of 2, so that is in place of x4, so that will be positive 2 whole raised to 4 minus p, we are substituting in this wherever there is x, and in place of x that will be 2 whole square plus q equal to 0. 2 raised to that comes to 16 minus 4, 2 square is 4, 4p plus q equal to 0. And if we take minus sign throughout, then it will become minus 16 plus 4p minus q equal to 0. Take minus 16 on the right hand side, we'll get 4p minus q equal to 16. Mark this as 1. Similarly, do f of 1 will find out. Okay, equal to 0. That means 1 raised to 4 minus p into 1 whole square plus q equal to 0. That is 1 minus p plus q equal to 0. Change the sign throughout, we'll get p minus q, and I'll take 1 on the other side, that will become positive 1. Okay, similar to this. So this will mark as 2. And I'm just going to do it here so that we don't move to the next page. So 4p minus q equal to 16 and p minus q equal to 1. Change the sign throughout, this will become plus, this will become minus, these two become minus, this becomes plus. Cancel, 4 minus 1 gives 3p, 16 minus 1 gives 15. 3 ones are 3, 3 5s are 15, we get p equal to 15. And then we'll use this and we'll substitute it in this equation too. So we'll get 15 minus q equal to 1. I'll take q on the right hand side, bring 1 on the left hand side, and we'll get q equal to, sorry, p is not equal to 15, p is equal to 5, sorry. So we change this as well. So we get q equal to 4. So let's see, p equal to 5, q equal to 4, p equal to 5, q equal to 4. So C is our correct choice in this case. Next question, question 7. The zeros of the quadratic polynomial x square plus 99x plus 127 are either both positive, both negative, one positive, one negative, or both equal. Well, looking at it, definitely you can say that they are not equal, and definitely you can say that both have got to be negative. Okay, when there is positive sign here, that means the zeros should come as negative. But we can show it over here. We'll compare this. So they get a equal to 1, comparing to the general form, b equal to 99, and c equal to 127. Okay, so alpha plus beta will take equal to minus b upon a. Okay, and that can be said as minus b is minus 99 upon a, so that is 1, that is equal to minus 99. Okay, and we'll get alpha into beta is c upon a, that is c is 127 and a is 1, so we get 127. Now something that we did to, that is kind of common sense here. When you add 2 and get negative, that means both alpha and beta have got to be negative. That is when you will get the value over here as negative. Okay, when it comes to multiplication, if both are negative, it becomes positive, and that is exactly what is happening here. So if alpha is negative, which is multiplied into beta, which is negative, these are two zeros. Okay, that means the product should always be positive. So this is what we are getting here, and in this case what we are getting here is negative because both of the zeros are negative. So is that both the zeros are negative. So B is our correct choice. Question 8 looks similar to question 7. The zeros of the quadratic polynomial x square plus kx plus k, where k is not equal to 0, cannot, the choices given are slightly different than the ones given, cannot be both be positive, cannot both be negative, are always unequal, are always unequal. Let's apply the same logic that we applied here over here. Okay, we'll compare the general formula. We get a equal to 1, b equal to k, and c equal to also k. Okay, then so alpha plus beta, which is equal to minus b upon a. In this case it will be minus b is k, so minus k upon a is 1, so which will equal to minus k, and alpha into beta is equal to c upon a. C is k, a is 1, which means equal to positive k. Okay, so same logic applies over here. That means when alpha is negative and when beta is negative, when they are added, the product also that we get will be negative. But when we multiply the two zeros which are negative, the product that we get will be positive. Okay, so from here what we can see, which is the choice? Cannot be both positive. Yes, cannot be both positive would be the correct one. Cannot be both negative. No, it is negative. Okay, we don't know anything about being equal and unequal over here. So from here, the information that we have been given, we can deduce that both cannot be positive. So our correct choice would be A in this regard. Question 9. If one of the zeros of a quadratic polynomial of the form x square plus ax plus b is the negative of the other zero, then it, and the choices given, the choices are quite interesting, you have to read them, has no linear term and the constant term is negative. Has no linear term, B choice, and the constant term is positive. Can have a linear term but the constant term is negative. Can have a linear term but the constant term is positive. Now, just having a glance at this, you can definitely make out that there is no linear term. Now, to tell you what is a linear term, if we take this itself, x square plus ax plus b, this is known as a quadratic term, okay, because the power. This is known as the linear term, power is 1, and this is known as the constant term. Okay, so what is the choices that we have is whether it has got a linear term or not. Okay, that you can easily make out reading that thing once again. It says the zeros, one of the zeros of the quadratic polynomial is the negative of the other. That means that the zeros that we get are the same, but they are of opposite signs. Something like this, x square minus 4. See, there is no linear term over here, and then constant term is negative. So our answer should be has no linear term and the constant term is negative. But we'll explore this possibility further. In this case, what happens? This is a square minus b square, which means it should become x minus 2 to x plus 2. You see, the numbers are the same, but one is of opposite sign of the other. That is what it says, is the one of the zeros is the negative of the other. That means one is positive, one is negative. So in this case, in such scenarios, then what happens is that you do not have a linear term because the linear term becomes 0. So it's like saying here a is equal to 0. Okay, if a is equal to 0, that means 0 into x will be 0, and there is no linear term. Now in case of this, it clearly shows you that only in such circumstances there is no linear term and the constant term has a negative sign. Okay, so remember, so A is our correct choice, by the way, has no linear term and the constant term is negative. Coming to the final question, question 10, it says which of the following is not a graph of a quadratic polynomial? We have been given 4 graphs. Now for a quadratic polynomial, okay, the number of zeros that are possible are 2, 1 or none. Okay, this is the number of zeros that are possible in case. So here you are asked which of the following is not a graph of the polynomial. So in the first case, okay, what it's over here, we look at the x-axis, whether this curve cuts the x-axis or not. Here it is not cutting the x-axis. If it cuts the x-axis, that means we get 1 0. Here it is not cutting, that means here it is not a 0. So but it can be a quadratic polynomial. In this case B, it cuts at one point. Okay, so it satisfies this. Okay, it can be a quadratic polynomial. In case of C, it cuts at 2 points, this one and this one. Okay, these 2 points, it can be a quadratic polynomial. What about D? D, if you have a look, it cuts at 1, 2 and 3 places on the x-axis. That means it will, this type of graph will give you 3 zeros and 3 zeros are not possible with a quadratic polynomial. With a cubic polynomial, yes, 3 zeros are possible. So quadratic polynomials can maximum they can give you 2 zeros, or they even no zeros also are possible. So 2, 1, 0, this is what is possible with a quadratic polynomial. Here there are 3 zeros possible, so we are asked to find out which one of these graphs is not a part of the quadratic polynomial, and it is D. So D is the choice. Okay, so this ends this set of MCQs that was requested by you. Okay, and this is only on polynomials. Like this, there will be more MCQs, short sets that will be done on various chapters that will help you to prepare for your examination. Okay, I hope you found this easy to follow. Please let me know in the comment section below how did you find this, whether you would like more such videos to be done. If you've liked watching this video, please hit the like button. Please do subscribe to the channel and please share it with as many friends and classmates as possible. Let them also benefit like you have. Okay, thank you very much for watching and keep watching for more such videos. Thank you.